So hello everyone, my name is Tivagar and I'm from Group 5. So today we are going to present about Assignment 2. We are tasked to design a simple database system using entity relationship diagram and implementing a case study database system using MS Access. So these are the objectives and I will give it to Azrai to continue presenting.
Okay, hello everyone. My name is Muhammad Azrai, and I'll be presenting our database system design for a library management system. So, for this session, I will cover two parts, which is the refined ER diagram and the normalization process up to third normal form. So, let's begin with the refined ER diagram. So, our focus is on the circulation subsystem, which handles borrowing, returning, and also fines. So there are four main entities involved, which is a member, book copy, transaction, and also fine. So member stores details about users such as member ID, name, and contact information. The second one is book copy, represents individual book items in the library, including the book copy ID, title, ISBN, and also status. So the third one is transaction, which records each borrowing or return with attributes like checkout date, due date, and also return date, and it links both the member and the book copy involved. So the fourth one is the fine which is generated if the book is written late, and it includes the amount and payment status. So we define clear relationships, like a member can have many transactions, and also each transaction involves one book copy, and a transaction can have one fine or none. So this ER diagram helps us to visualize the structure of our system and how the data is interrelated. And then the next one, I'm going to present about the normalization from the unnormalized form to the first normal form. So this unnormalized form that store all data in a single flat table, including member book, transaction, fine, and fine data all together. So to convert this into a first normal form, we remove any repeating groups. So we split the data into separate entities like member, book copy, transaction, and also fine, each with atomic attributes. So the second one is the second normal form. So we made sure that all attributes fully depended on the primary key. So we avoided partial dependency by separating book and member details into their own tables. So now each transaction is only dependent on a unique transaction ID. So the third one is the third normal form. So we remove transitive dependencies. For example, find details like amount and status don't directly relate to the transaction score data. So we move them to a new find table linked by the transaction ID. And this avoid unnecessary null values, and it gives us flexibility to manage fines and more easily in the future. We choose this design to reduce redundancy, improve data integrity, and allow for future scalability. So for example, the fine table can later include payment tracking without changing the core borrowing system. So next, I'm going to pass to my other teammates to explain further. Thank you.
Hello, my name is Alia Patricia, and I'm handling question number 3 and 4, which is question 3, database information in MS Access. All right, for question 3, we focus on building the actual database using Microsoft Access. This involves 4 main tables: user, book, loan, and fine. Each table had a specific role. The user table stores basic information like name, contact, and address. Each user has a unique ID. And then the book table had lists all the books, including details like title, author, ISBN, and the book's current status, whether it's available, borrowed, or lost. Mm, the loan table record when a user borrow a book, it links the user to the book with foreign key and includes loan due date and return date. The fine table handles fine. If a loan has a fine, it gets linked here, including the amount and whether it's paid or unpaid. Also, we set up relationship between the tables with referential integrity to ensure data consistency. For example, one user can have many loans. One book can be borrowed in multiple loans, and each loan can have zero or one fine. After setting this up, we populated each table with 10 samples record to test everything and make sure our structure works properly. So the goal here was to make sure the database was not only well structured, but also ready to handle real data in a library setting. So for question number 4, which is the SQL query set. Moving on to question 4, this part focuses on using SQL queries to interact with our database. We divided into 3 main parts. DDL, data definition language. This is where we create and modify tables. For example, we use create table to build book table. We also use alter table to add publisher field. For DML, data manipulation language, this is all about adding and changing data. For example, insert was used to add a new user, update, change a book status to borrowed, delete was used to remove a fine record. And then for number 3, we have select statement. These are for retrieving useful information. We did a join to display which user borrowed which book and when. And then we have as a aggregate function like count that help us see how many books each user borrowed. A subquery was used to list user who have overdue book that they haven't written yet. So these queries help us demonstrate how powerful SQL is when managing and retrieving data in a structured way. So that's all for my part. I will pass to my teammate for the next part.
So hello again. I'll be presenting the SQL query set we developed for our library management system. We implemented a total of 8 SQL queries split across 3 categories, which is DDL, DML, and select statements. For DDL, or data definition language, we created a modified tables using create table and alter table statements. For example, we create user form, book form, and loan form, and also find form. Next, we use DML or data manipulation language for inserting, updating, and deleting records. We inserted users' data. We also updated book status and deleted a fine record using simple but meaningful queries. Uh, Lastly, we showcase select queries, including joins and subqueries. One example is join displays who borrowed which book and when. We also used aggregate function to count total loans um, per user and a subquery to list overdue users. Overall, these queries validate and demonstrate the effectiveness of our database system in managing real-world library operations. For the user interface, although it's optional, we created basic forms in MS Access to make the system more user-friendly for library staff. We designed the following form such as this, and each form was structured with clear labels, and we added drop-downs where needed to minimize input errors. For only instance, the book status field only allows available, borrowed, or lost. And moving on to question 6. For part 6, we reflected on our teamwork and how the tasks to be distributed. What we actually worked, worked on was our group had strong planning early. We had open communication. We also had understanding among each other. Also, developing and testing the SQL code went smoothly, thanks to peer review sessions and clear collaboration. Also, the challenges we took was the hardest part was maintaining integrity and managing foreign keys in MS Access. Getting relationship to work correctly took extra effort, and we also had to manage our time well because we were working on other assignments too. So, in terms of task distribution, one member focused on the database schema and defining relationship between tables like users, book, loan, and find. So, finally, uh, we use shared folder and regular meetings to keep everything organized. For our final project, uh, we intend to make several significant improvements for the finished project, such as user interface, error handling and validation, automation, and testing review. So that's all from us. Thank you.
Thank you.